Look at a map of Canada, and something strange starts to happen. You could draw a single red line across it, and that line would separate almost the entire population from almost the entire country. Above the line, two-thirds of Canada's landmass. Below it, more than 90% of its people. Canada is the second largest country on Earth by area, and by density, one of the emptiest. Roughly 4 people per square kilometer on average, lower than Kazakhstan, lower than Libya, lower than almost anywhere else with a G7 economy. But that emptiness was never random. It isn't cold alone, or distance alone, or policy alone. It's rock. Rock that finished forming before there was abundant oxygen in Earth's atmosphere, before complex life existed, before the continents looked anything like they do now. That rock has a name, the Canadian Shield, and understanding it means understanding why one of the richest, most stable nations on Earth has spent over a century failing to fill in its own map. This is the story of the ground that said no. The Canadian Shield is a single continuous slab of Precambrian bedrock, covering roughly 8 million square kilometers, curling around Hudson Bay like a horseshoe, and stretching from the Arctic Ocean down into the Great Lakes. It covers about half of Canada's entire landmass, along with parts of Minnesota, Wisconsin, Michigan, and New York. The name comes from geologists, who noticed it forms a raised, shield-shaped core around the bay, with younger sedimentary rock layered against its edges like the rim of a bowl. Most of the rock underneath it is somewhere between 1 and 4 billion years old. In 1989, geologist Samuel Bowring and his colleagues dated a rock outcrop on the shores of the Acasta River in the Northwest Territories to roughly 4 billion and 3 million years old. The Acasta gneiss, as it's called, remains one of the oldest known intact rock formations on the planet. The shield isn't flat because it was born flat. It's flat because it's old enough to have been worn down. Entire mountain ranges rose and eroded away across it, cycle after cycle, over roughly 3 billion years of tectonic activity, until what remained was a low, ancient, almost featureless plateau of exposed granite and gneiss. By the time humans arrived in North America, the shield had already been geologically quiet and slowly grinding down for longer than most rock on Earth has existed at all. Then came the ice. Beginning around 100,000 years ago and peaking roughly 20,000 years ago, the Laurentide Ice Sheet buried nearly all of what is now Canada, under ice more than 3 kilometers thick in places. At its maximum, the Laurentide Ice Sheet alone held enough frozen water to lower global sea levels by over 100 meters. Ice that thick doesn't just sit on the land. It moves, slowly, under its own weight, dragging rock and sediment across the surface beneath it like sandpaper the size of a continent. Across most of the Canadian Shield, that grinding didn't just move loose soil. It stripped the land down to bare bedrock, scouring away tens of thousands of years of accumulated topsoil in the process. When the Laurentide Ice Sheet finally retreated, starting around 14,000 years ago and largely finished by about 10,000 years ago, it left behind a landscape that looked less like farmland and more like an exposed skeleton. It also left behind water, an almost incomprehensible amount of it. According to Natural Resources Canada, the country contains an estimated 2 million lakes, and by most estimates, close to 60% of the world's lakes by number. Most of those lakes sit directly on the shield, in shallow depressions gouged out by moving ice, with no natural drainage and bare rock walls instead of soil banks. It is also, agriculturally speaking, close to useless. Farming requires topsoil, a layer of decomposed organic material and fine mineral particles built up over thousands of years. Across most of the shield, that layer simply isn't there anymore. The glaciers took it, and 10,000 years hasn't been enough time to rebuild it. Where soil does exist on the shield, it's often only centimeters deep, sitting directly on solid granite, unable to hold enough water or nutrients to support large-scale crops. There are exceptions, and they prove the rule. In northern Ontario and Quebec, a region called the Clay Belt has unusually good soil, but not because the shield's rock changed. It's because a massive glacial lake, known to geologists as Lake Barlow Ojibwe, sat there for centuries after the ice retreated, depositing fine lake bottom clay over the bedrock before draining away. Everywhere else, the rule holds. No ancient lakebed, no soil, no farms, no cities built on farming economies. This mattered enormously once European settlement began in earnest. The Hudson's Bay Company, chartered in 1670, built its early economy on the fur trade, which depended on rivers and lakes as highways, not on farmland. Its trading posts spread across the shield along waterways, but they were never meant to become cities. Real permanent settlement, the kind that grows into cities, needed food security first. And food security needed soil that the shield, for the most part, did not have. So settlers went around it. the St. Lawrence lowlands, where Montreal and Quebec City sit, are not on the shield at all. They're a strip of sedimentary rock and glacial soil deposits squeezed between the shield and the Appalachian foothills, some of the best farmland in the country. So do the prairie provinces further west, sitting atop the sedimentary Western Canada Sedimentary Basin, which is why Saskatchewan and Alberta could become some of the most productive wheat-growing regions on the planet. Every one of Canada's major population centers, Toronto, Montreal, Ottawa, Winnipeg, Calgary, Edmonton, sits either south of the shield's edge or in one of the rare sedimentary gaps that interrupt it. This is not a coincidence repeated by accident 5 separate times. It's the same constraint, expressing itself the same way, everywhere it appears on the map. In the 1880s, Canada tried to defy that constraint directly. The Canadian Pacific Railway was built partly as a political project, binding British Columbia to the rest of the Confederation with a physical line of steel, completed in 1885. To do it, engineers had to cross the shield north of Lake Superior, through a stretch of country surveyors at the time described as some of the most difficult terrain they had ever tried to build through. Construction crews faced solid granite ridges that had to be blasted apart meter by meter, and muskeg, waterlogged peat bog sitting directly on impermeable bedrock that could swallow entire sections of track overnight. The line north of Lake Superior alone is estimated to have cost far more per kilometer than almost any other section of the Transcontinental Railway. But the railway did accidentally produce one of the shield's few economic success stories. In 1883, blasting for the CPR near a site that would become Sudbury exposed a massive deposit of nickel and copper sulfide ore. That deposit, the Sudbury Basin, turned out to be one of the largest nickel-copper ore bodies ever found, and current research suggests it was created not by ordinary volcanic activity, but by the impact of a large meteorite, roughly 1.8 billion years ago. It is a rare case where the shield's ancient violence became an economic asset instead of an obstacle. But mining towns are not the same as agricultural cities. It cannot support the dense, self-sustaining food systems that let populations grow into the millions, the way Toronto or Montreal did. Statistics Canada geographers use a specific term for the settled portion of the country, the ecumene, meaning the part of the landmass that's permanently and densely inhabited. Canada's ecumene is a surprisingly thin band, hugging the southern border and a handful of resource towns further north. By most Statistics Canada estimates, somewhere between 2/3 and 3/4 of the entire population lives within 150 kilometers of the border with the United States. That's not a cultural preference for being near American shopping malls. It's the geological line where the shield's ancient bedrock finally gives way to farmable ground. Meanwhile, the 3 northern territories, Yukon, the Northwest Territories, and Nunavut, cover close to 40% of Canada's total land area. Combined, their population is a little over 100,000 people. Nunavut alone is roughly the size of Western Europe. This isn't a failure of ambition. Canada has tried, repeatedly, to push settlement north. Mining towns, hydroelectric projects, military outposts, and Indigenous communities all exist scattered across the shield and beyond it. But every one of them depends on supply lines stretching hundreds or thousands of kilometers back to the ecumene, because the ground beneath them still can't grow enough food to feed even a fraction of the people living on it. Many northern communities today are only reachable by seasonal ice roads, built each winter across frozen lakes and rivers, because no permanent road can be justified for the number of people it would serve. This is what 4 billion years of geology does to a modern economy. It doesn't just shape where cities can grow, it sets a price on every single kilometer beyond the line. A price that has never gotten cheap enough to erase, no matter how advanced the technology or how strong the political will. And that price is now being renegotiated, whether Canada wants it to be or not. The Arctic is warming roughly 3 to 4 times faster than the global average, according to multiple federal and international climate assessments. At the same time, that same warming is slowly opening the Northwest Passage, a sea route through the Canadian Arctic archipelago that explorers died trying to find for nearly 3 centuries. A genuinely navigable Arctic shipping route would cut thousands of kilometers off voyages between the Atlantic and Pacific, and every major shipping and naval power on Earth already knows it. Canada claims the passage as internal waters. It's a sovereignty dispute that barely mattered when the region was locked in ice most of the year, and matters enormously now that it might not be. Russia has already built and deployed dozens of icebreakers and expanded military infrastructure across its own Arctic coastline. Canada, with the longest Arctic coastline of any nation, has historically maintained only a small permanent military and civilian presence across the same vast northern two-thirds of the country the shield helped keep empty for 4 billion years. The very geology that made the North nearly unlivable for farming is now colliding with a climate-driven shift that makes the same North strategically valuable for the first time in human history. None of this erases the underlying fact. The rock is still there. The soil still isn't. Nunavut itself was created in 1999, carved out of the Northwest Territories specifically as a homeland for the Inuit, following one of the largest Indigenous land claim agreements in Canadian history. It represents an entirely different relationship with this land than the one European settlement ever managed to build. One based on movement, adaptation, and seasonal knowledge, rather than the fixed, soil-dependent settlement that farming economies require. Which raises an uncomfortable question for the rest of the country. If nearly a century and a half of railways, mining booms, and federal investment couldn't meaningfully fill in that map, what would it actually take? Some economists and geographers argue the honest answer is that it shouldn't be filled in at all. That the shield's emptiness, uneconomical as it looks on a population density chart, might be one of Canada's most valuable long-term assets, precisely because it stayed empty. The shield and the boreal forest sitting across much of it together hold one of the largest intact carbon reservoirs on Earth. In a warming world, land that failed to become farmland might matter more intact than it ever would have as failed cropland. The same ancient stubborn rock that made this country impossible to fill in evenly might now be one of the reasons the rest of the planet can afford to keep breathing. Every time you picture Canada, you're probably picturing the thin green ribbon along the border, the cities, the highways, the farmland. That's not a mistake. But it means you're picturing roughly a third of the country and ignoring a stretch of ancient stone bigger than most nations on Earth. A landscape old enough to have existed before oxygen filled the sky, scraped bare by ice that outweighed anything alive today, and left, ever since, almost entirely alone. Humans did not choose to leave 90% of Canada empty out of a lack of ambition, or a lack of ingenuity, or a failure of national will. They ran into a piece of ground that had already decided the terms 4 billion years before anyone showed up to negotiate. It's easy to think of a country's shape as a human decision, drawn by treaties and settlers and surveyors with a pen. Canada's shape on a population map was drawn far earlier than that, by ice a kilometer thick, moving across rock nearly as old as the planet itself. It's a border between two timescales, one measured in centuries of human settlement, and one measured in billions of years of geological patience. And for now, at least, the older timescale is still winning.